Hi students, welcome to Engineering Graphics class. I am Dr. Vinodkumar, Adjunct Professor at QSAT Kochi. Developmental surfaces 1. What is developmental surfaces? Developmental surfaces is the shape of the surface of an object, of a solid. If you assume you are wrapping a paper around a prism or a cylinder or a cone or a pyramid, and if you take out, unfold the paper from the surface, from the body and show it, that is called the developmental surface. Agreed? Developmental surface become extremely important in manufacturing shapes with the help of plates and sheets. When you produce the shape of the hull of a ship, you need to know what is the shape. You will take metal sheets and bend it in the appropriate form and then weld them together. Similarly is the case when you make the body of a car. Agreed? You need to know the actual shape. Those pieces are made separately and then they are welded together, and finally when you paint it properly, it becomes the beautiful shape of the car. Similarly, even our dresses are produced like that, but if you assume your dress is very tight, then it is purely development. Usually our dresses are loose, but it can use the concept of developmental surfaces. Agreed? We first of all see development of prisms. I am going to take a prism, a pentagonal prism in this case, of 25 mm side and 60 mm axis, and then cut this. I draw the development, and then I cut it with the various cutting planes, and I make the appropriate changes in the development. When you develop the lateral surface of an object only, you say development of lateral surface. If you add up the top and the bottom in the case of prisms or cylinders, and if you add the bottom only in the case of a pyramid and a cone, you get total development. Agreed? So total development includes the top and bottom, and the development of the lateral surface include only the lateral sides of the or lateral surfaces of the object. In this case, we are going to draw the total development. If you are asked to draw lateral surface, you can ignore the top and bottom. So this is the plan and elevation of a pentagonal prism. Standing on its base on HP, I have preferred a side to be parallel to VP. You can keep it in any position. My idea is to give you certain concepts. These concepts will be used in solving other questions. Okay, I have preferred to keep one side parallel to VP so that A, B, C, D, E, the bottom corners, F, G, H, I, J, the top corners, OP, the axis, A dash, B dash, C dash, D dash, E dash, O dash, points on the base, F dash, G dash, H dash, I dash, J dash, P dash, points on the top, and I have completed the elevation. I have marked the dimensions in the plan and the elevation. Now, if you assume you wrap a paper around the body, including the top and bottom, and then you cut the first vertical edge. What is the first vertical edge? AF. If you cut the first vertical edge, if you cut the paper with a blade along the first vertical edge and on the top and at the bottom, and if you take out, what is the development of the lateral surface? Development of the lateral surface will be, if this is 25 mm, 5 pieces of 25 mm, 5 pieces of 25 mm whose height is equal to axis, say 60. I choose capital A here. In development we use capital letters. Capital A, then 25 mm away, capital B, C, D, E, and again A. A and A together, when you bring together, becomes the A on the object. So A and A together form the point on the object. So this is A, this also is A. The height, these vertical edges are drawn assuming marks are produced on the paper. When you fold the paper around the body, you assume there are impressions produced on the paper. So these are those impressions. F, G, H, I, J, F, A, F, B, G, C, H, D, I, and E, J, and finally A, F are the 5 vertical edges reproduced in the development. And at any of these pieces, draw a pentagon. What this represents? It represents the base. If this is A, this is B, C, D, E. If you fold it, this will come to the corresponding positions, and I have drawn the top also. This can be drawn anywhere. If you add these two, it becomes total development. If you ignore these two, it becomes development of lateral surface. Oh, this is a plan, elevation, and development of the prism. Agreed? Now, I am going to cut it by various kinds of cutting planes. One cutting plane is parallel to HP bisecting the axis. VT, parallel to HP bisecting the axis. How many vertical edges does it cut? It cut all the 5 vertical edges. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Now what differences does it produce in the section? I mean in the development. When you cut this what happens? You remove the top. Then what happens? Draw a horizontal line in the same level. 1, 2, 3, 4, 5, 1. Once you darken these vertical edges indicating that the bottom is kept, you have to darken these vertical edges also to indicate that the bottom is kept and the top is removed. So this is the development of the cut prism. Development of the cut pentagonal prism. Where is the cutting plane? Cutting plane is passing through the center. Cutting plane is passing through the center, bisecting the axis. I have assumed like that. You can use it, cut it anywhere, but it's a horizontal line. That is what I intend to convey to you. Agreed? In this cutting plane, the second cutting plane, I am going to cut it by a cutting plane, cutting all the 5 vertical edges. It cut all the 5 vertical edges. Cut all the 5 vertical edges. You have to darken this portion below the cutting plane. I am not doing that because the top is removed. You have to darken the portion below that. Okay. How many vertical edges? 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. You have to darken the portion below the cutting plane. Now, what all changes does it bring in this development? A dash F dash is cut by 1. So, draw a very light horizontal line. 1. Extend that horizontal line. 1. Same level. Because there is an AF, there is another AF there. So, both AF will have the point equal to 1. 2. 2 dash. Draw a horizontal line through 2 dash. 2. Where is 2? 2 is on BG. BG. So, BG will have 2. Then 3. 3. Where is 3? 3 is on CH. C dash H dash. So, this CH will have 3. Then 4. 5. Agreed? Connect them. 1 to 2. 2 to 3. 3 to 4. 4 to 5. 5 to 1. Individual straight lines. Individual straight lines connecting 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 1. You can darken these lines below the cutting plane. Below the cutting plane. Keeping the top light indicating that the top part is removed. Okay. This is the second cutting plane. In the third cutting plane, I am keeping it there. In the third cutting plane, where is it? The third cutting plane I am taking, cutting the top. Let it cut the top like this. VT. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. You have seen a similar cutting plane in sectional solids. Cutting the top. Darken the portion below the cutting plane. I am not doing that. Then when you come to the development, 1 dash is on AF. So 1 and the same level here, another 1. 2, 2. 5, 5. Where is 5? 5 is on DI. So this DI will have 5. 6 EJ, draw a horizontal line. I am not completely drawing those lines. You will have 6. Now, what about 3 and 4? If you draw a horizontal line through 3 dash 4 dash, it will just coincide. Where is actually 3? 3 is on, or 3 dash is on G dash H dash, and 4 dash is on H dash I dash. Drop them to the plan. You get 3, 4. GH3, HI4. This GH is equal to this GH. Agreed? Take this distance G3 and mark. You get 3. What is the criteria? G3 equals small g3 from plan. Similarly, HI will have 4. Take this H4 and mark here 4. H4 equals small h4 from plan. Connect them. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1. Individual straight lines. When G 3 and 4 on GH and HI, this GH and HI will have 3 and 4. On the way from G to H, nearer to H is 3. On the way from G to H, nearest to H is 3. On the way from H to I, you have got 4. On the way from H to I, you have got 4. That means you have to connect 3, 4 there. Connect 3 and 4 there. Now, you have to darken the portion below the cutting plane and keep the other portion light. So, you have to darken these lines. Agreed? This pentagon also. This pentagon, small piece of the pentagon, you have to darken. This small piece you have to darken because that is kept. The other things you have to keep light. This is the third cutting plane where the cutting plane cut the top of the prism. In the next cutting plane, the cutting plane is drawn in the plan. The cutting plane makes 50 degrees to VP, passing through a point or passing through 10 mm away from the vertical axis. So what do you do? Draw somewhere a line at 50 degrees to XY, draw an arc with the 10 mm radius, then tangential to the arc and parallel to this line we will draw the cutting plane. We have drawn similar cutting planes in section of solids. Where does it cut? Cut the base at AB at 1, then above that at 2, here above 3, bottom 4. 1, 2, 1, 2, 3, 4. If you project them to the elevation, you will get 1 dash, 2 dash, 3 dash, 4 dash. That is the sectional view part. I am not drawing that. Coming to the development, A to B. On the way from A to B, you have got 1. On the way from A to B, you have got 1. What is the distance taken? 1 is on AB. Similarly, 2 is on FG. 3 is on HI. 4 is on CD. So, where is 1? 1 is on AB. Which distance? On the way from this AB is equal to this AB. So, take this distance and mark. You get 1. Exactly above is 2. And similarly, on this AB, mark 1. And on this FG, mark 2. Then, 3. 3 is on HI. Take this distance. HI. On the way from H to I, 3. Below that is 4. On the way from H to I is 3. And C to D is 4. Join 1, 2, 3, 4. Join 2, 3, join 1, 4. That completes the development. Now, when you cut this part is removed. Which part is removed? The part containing BG and CH are removed. So, the part containing BG and CH in between these two lines, inside these two lines are kept light and the remaining are kept dark. Then, on the top and bottom, BG and BC portion is removed, so this has to be dark. This is removed, so this has to be dark. This completes the fourth cutting plane. We have drawn therefore 4 types of cutting planes in prisms and tried to learn some basic points. Where are the points coming? How are they marked in the development? Agreed? Using this concept, we will have to draw on other prisms and other prisms, square prism, pentagonal, hexagonal prism and triangular prism. We will see pyramids, cone, and cylinders separately like this. These concepts are to be used in prisms. We will draw separate university questions where cutting planes are there on prisms. We will do those university questions separately. There are numerous cases where prisms in various orientations are cut by various kinds of cutting planes. We will see them while solving university questions. Okay. Thank you.